states have more? Is it less likely to be found?
What would that be?
Because it wants to move around more.
Now they said to, was this what you got? 2.6?
Yeah.
They said to consider the first excited state. What would n be for the first excited state?
N equals 2.
So that means we should be able to fit 2 half wavelengths in. And we're trying to figure out this area over here. Just from looking at it, it kind of seems like maybe this would be a little higher than this one over here. This is a little bit closer to the peak, because this is going to peak at 0.75. This is pretty close to where it peaks, whereas this one peaked at 0.5. This one peaks at 0.5, but this one is going to, this peak is going to be at 0.75. So just by drawing the pictures, it looks like this height over here, it's not really reflected in my pictures here, but it looks like this height here should be bigger than this height, because 0.7 is not that close to the peak here. The peak here was halfway through at 0.5, whereas 0.7 is pretty close to this peak, which is 0.75.
Wait, what does the peak mean?
The highest probability. Remember that this is the chi-squared function?
Yeah.
This is the function that tells us the probabilities.
Oh, so
How did I know that it looks like this? Well, from the n. Remember that we're really fitting in standing waves here. We're fitting in standing waves, well, that have nodes at both ends. There always has to be a node at both ends. Well, n equals 1 is when you put in 1 half wavelength. N equals 2 is when you fit in 2 half wavelengths. So that's how I knew that these two pictures look like this. But you know, I guess we could check it because we could just use the same formula that we used up here. Except the only difference is that instead of plugging in 1 for n, what should we plug in?
2.
So I'll just put in the number 2 here. So what does that give us in this sine function?
1.4 pi.
So let's just check it by doing this calculation on your calculator.
2 sine 1.4 pi squared.
Good.
So that's more.
0.00036. Is that what you got?
Yeah. So does that mean it's more likely to be found?
Yeah, because that's what we're calculating here, the probabilities, right? Remember that the area under the curve is the probability, or the integral of the chi-squared function is the probability. So I think they wanted you to do this one without doing the calculations, just by drawing the pictures. By drawing the pictures here, you have to note that for n equals 1, you fit in 1 half wavelength, and for n equals 2, you fit in 2 half wavelengths. And then, well here, 0.7 is really not that close to the peak. The peak here is at 0.5, whereas 0.7 I think is pretty close to this peak. All right, but you can always double check that by plugging into the formula. Okay.